Welcome back, nerds. New section today. Section 1.3, characteristics of functions. But come to be real with you, the authors didn't want this section to start with this material. Actually, nothing on the front of this is in this section. The actual material for the section starts back here, but I don't like just telling students things without them knowing why they're true. So I'm going to take the time to teach you things before I start teaching you other things that you wouldn't know why they're true. There we go. I got those words out. Anyway, a little bit of review. We've already talked about domain and range. But just to remind you what the domain is, the domain is the set of all the x values that your graph can quote-unquote cover, meaning all the x values that you're allowed to plug in or all the x values that exist for the graph. And the range is the exact same setup, except for it's the y values. So the range is all of the y values that our graph covers. It's all the possible outputs of a graph. Intercept means to cross. So an x-intercept is just where our graph crosses the x-axis, and the y-intercept is just where our graph crosses the y-axis. I didn't say y-axis twice, did I? Did I? Too bad I don't know how to edit these videos. X-intercept is where you cross the x-axis. Y-intercept is where you cross the y-axis. Alright. So positive and negative is going to be the interval of values that describe where our graph is above the x-axis and where our graph is below the x-axis. What do I mean by that? I mean like this. At x equals 5, I'm just going to say, at x equals 5, does our graph have a positive y value or a negative y value? And that's what we mean by that. So when we say positive and negative, we mean the y values would have been positive here. The y values would have been negative here. But we use the x values to describe where we are. So on a graph, when you say where does something happen, you're using x values. Same thing for increasing and decreasing. We're using x values to describe where our graph has positive slopes or where our graph has negative slopes. And you might be asking, what do you mean by a graph having slopes? I thought that only straight lines had slopes. You go, well, no, not really. Okay. Even curves have slopes. For example, this curve right here, I could say has a slope. At x equals -5, what you would do is imagine that there was a straight line at x equals -5 that touches the graph without going through it. And if you don't have to do this, if you were to have drawn this line that I just created with this blue ruler, this line would have a positive slope. So we say that this graph has a positive slope at that value. So anywhere our graphs have positive slopes, we say the graph is increasing. And anywhere our graphs have negative slopes, we say the graph is decreasing. The easiest way to think about this is roller coasters. That's the example I use every time I teach this material, is roller coasters. We will treat this graph as the track of a roller coaster when we get to the increasing and decreasing stuff. So until then, let's do the other 4. And by the way, domain, positive, negative, increasing, decreasing, these all describe where our graph has certain behaviors. So all 5 of these will use an x interval. That's the only one that uses a y interval, the range. It's the only one that uses the y values. So all of these other ones, we will mention nothing but x's. This one, we'll mention the y's. Our domain is all of the x values that our graph covers up. Do I have a brave volunteer that wants to tell me what they think the domain is in integral notation? Seeing that this arrow points down into the left. Sorry, this arrow points down into the left, and that is an endpoint. No brave volunteers. Okay, Ryan, what do you got for me? Yeah? Sounds good to me. This is -infinity to 8 with a bracket on the 8 because it is a closed dot. Perfect. Remember, we never include infinities because they are not actual numbers. They're goals. Great. So following his lead on small to big x's, Who could do the same thing but for the range for me? Looking for names because I don't know it yet. And I don't want to call on victims. Barry? Hey, I got it right. Barry. Yeah, let's go to 5 and change, like 5.2 or something. But yeah, negative infinity up to that 5.2. Now let me ask you what's going on up here. Parentheses or bracket? Bracket, good, because it's an actual point on the graph. Perfect. If there's any questions at all about domain range and why we did what we did, please say something. Let me help out. I can explain it different, or I can get a different graph, or anything. No. Everybody's cool? Okay. Awesome. Okay, so let's get to positive and negative. The rest of these are all going to be x values. X values where things happen. If I'm describing above the x-axis or below the x-axis, what kind of points should I be looking at to create my zone, like my barrier zones? How do I know that I'm above or below the x-axis? What kind of point do I look at? It's in the box. Right, I'll be the dentist, I'll pull the teeth. The x-intercepts, you know, where your graph crosses through the x-axis, lets you know if you're above or below the x-axis. So, the x-intercepts are going to create my zones. The very first zone, way over there, is that going to be a positive or a negative zone? You can shout it out, yeah. Negative. Yeah, because I'm below the x-axis. So how do I describe that first zone where I'm below the x-axis, where it's negative? Well, I have to say what the farthest value on my domain is, because, you know, we're going to the left. And we will have to estimate where that x-intercept is. I don't know, negative 5.8, something like that. Good. Okay, now hold on a second. The question now becomes, what symbol do I use? Remember what I said when we're talking about positive, negative? What we're saying is the y values. Are they positive there or negative there? So right here at this x-intercept, what is my y value? What's its numeric value? 0, yeah. And is 0 a positive number or a negative number? Oh, it's neither. Okay. So since it is neither positive nor negative, I can't put a bracket on that. Now I'm in this zone where I have positive y values. So that zone is going to begin where the last one ended. And it's going to end right there at negative 2 change. Negative 2.2. After this x-intercept, we're back below the x-axis. And we go all the way up to 0 for that zone. So negative 2.2 up to 0. And now all we have to do is finish out our domain. 0 to 8. And since 8 is an endpoint that is not on the x-axis, we will bracket it. Because yes, that is the end, and yes, that is a positive value. Well, a positive y value at x equals 8. So did we all buy the logic on why there's no brackets on the x-intercepts? Because there y is 0, which is neither a positive nor a negative number? One person should there. Sometimes we have to teach things we don't agree with. And you probably don't hear that very often in mathematics. But I'm about to have to teach you something in a way that I don't like. But I'm going to teach you this way because this is the feeder course for AP Pre-Calc, which is the feeder course for AP Calculus. All AP exams are written by College Board, and within the last few years they have decided something I find controversial in mathematics belongs on their stuff. So I will teach it that way. It has to do with increasing and decreasing. First, I told you about a roller coaster, right? In English, we read from left to right. And we actually count from left to right. 1, 2, 3, 4, 5. You see, that goes from left to right. In fact, if we say counting backwards, we literally go 10, 9, 8, 7, 6, 5. So we're actually going to the left. So it's just natural that we go from left to right. We're going to ride these roller coasters from left to right. Okay, so there we are. Thrilled about riding this roller coaster. But as we go, quote unquote, towards the right, what's this roller coaster car going to do? Is it going to go up or down? It's going to go up, right? What that tells us is, right now, at the very edge of our domain, from x, approach x all the way out at negative infinity, heading towards somewhere, our graph is increasing. Our roller coaster car is climbing. But I would be looking for, let's see, there's 30 of you, one absent, 29 voices to all give me an answer. It's okay if some of them are wrong. At what x value do you think my roller coaster stops increasing? Class? So, I heard a mixed bag of answers, but it definitely wasn't my whole class. That's discipline. Now here's the two answers I heard. I heard 3, and I heard -4. -4 is the x value where we stop increasing. 3 happens to be the y value we reach up to. But when we describe where things are occurring, we only refer to the x's. So when we say positive, negative, increasing, decreasing, we only do the x's. And I was hoping it wouldn't happen, but habit already got me. I've already made a mistake, according to College Board. Right here, at this point in space, would you say you are increasing, decreasing, both, or neither? See, I believe it's neither as well, which would mean you can't put a bracket there. That's what I was taught. The College Board says, no, it's both. College Board says right here, and I don't agree with this, that our graph is both increasing and decreasing at the exact same time. Who am I to argue, right? I just have to agree. But, whatever. Yes. Yep. So every time we have a barrier where increasing, decreasing changes, College Board says it's doing both. So you have to use a bracket there. But not for positive, negative. I guess because the argument is that 0 is not positive and 0 is not negative. But I would also argue that calculus tells me that right here, these slopes are positive. Right here, these slopes are negative. And right there at that point, the slope is 0, which is not positive, and it's also not negative. But again, who am I? This is what College Board wants, so this is what we're going to learn to make sure that when you go to AP Pre-Calculus next year, if you go to AP Pre-Calculus next year, you're ready for it. Now, if you're currently a senior sitting in this course and you're not going to AP Pre-Calculus next year, you'll be going to college and you'll do college algebra and pre-calc there. Basically, you do whatever your professor wants. Those are the rules. Cool? we have to listen to Professor College for. So right here, we will start decreasing at x equals -4. And again, I'm looking for 29 voices. Class, at what x value will my roller coaster stop decreasing? There it is, -2. Lots and lots and lots of correct answers at -2. Where I once again begin increasing. What I want to know is, at what x value do I stop increasing? Class? Whoa. Maybe people were writing. But yeah, it's at 3. It was very sporadic. It's frightening. But then after that, my graph does fall, and we fall all the way until 8. Where we close out the domain. I also want it to be known that I firmly disagree with this bracket right here as well, because of calculus. But is there any lingering doubt or anything I can clear up for anybody about what it means to be increasing, decreasing? Maybe you need another example, maybe you need a different explanation, maybe you just need me to re-explain what I already said. Anything I can do for you? Yes, Brock. Oh, I was just saying that we even say it's counting backwards when you go 10, 9, 8, 7, 6. Meaning it's just natural for us to always go from left to right, is all I was saying. Just saying, like, just it's natural for us to go left to right. So read the graphs the same way. Anything else? No? All right. So before we go ahead and do the exact same stuff for this graph, I want to make it a slightly different graph just because why not? Right here where I put this arrow, I want to change that from an arrow to an open dot. Just I like it better, and I'll even say it's open there. There, that's an open space. Not a, whoa, the screen got right on me. And right here where I have a dot, let's make it an arrow. This way it's a different kind of example compared to the one we just did. And I'll be looking for that brave volunteer that can hit me with the domain of this graph. You already did one for me though, Ryan. I mean, I really appreciate you. I'm trying to learn people's names. There's so many people in this room whose name I don't know. Like his. What's your name? Thomas. I knew where you were on my roster, but see, that's cheating. I need to know your name. Okay, Thomas, what do you think the domain is? Perfect. -8 to infinity, all parentheses, all around. Good. And do I have somebody that would be brave enough to estimate the range for me? Maybe one of the ladies whom I never hear from. Okay, you're not one of the ladies. What's your name? Jake. And I'm going to remind you, intervals always go from small to big. Okay. The range? That's domain. Yeah. Estimate it. Don't worry about it. Sure, let's call it 4.5. Where do I go? Brackets, parentheses. You said -4 to 4.5. Yes. Yep. Just like that. Perfect. Yeah, we have a bracket down here because this is an actual point on the graph, whereas this is not. Good. Okay, I'm going to go ahead and identify the x-intercepts because the x-intercepts are going to be our boundary zones between positive and negative. And I'm going to remind you that when you describe positive and negative, we don't use brackets on the boundaries. I'd say that one's, we just call that one 0.5, I'd say. That one's perfect, that one's perfect, that one's perfect. Here we go. Okay, looking for those brave volunteers. Like I said, maybe you need one of the ladies, because most of them I don't know yet. Because their names I don't know yet. I'm gonna get one of those random name generators. I'm just gonna start pulling names out of hats and have them scare people on blast. They don't want that. Come on, nobody can give me a positive interval other than Ryan and Brock. I mean, I love that you guys want to help me. I really do. I want to know everybody's names. Do you hear this, 8th period parents? Nobody. All right. I'll be the dentist. These teeth. To the left of this dot, we're above the x-axis. Doesn't this seem so boring all of a sudden? I know. We stop being above the x-axis around negative 6.5. But from that number to that number, we'll be below the x-axis. But my values are negative. I gotta tell you, it's much more interesting when my classes talk to me. Yeah. Have I, uh-oh, 2 hands went up. Maybe I made a mistake somewhere. I don't know. But, well, I was getting there. I was getting there. Brody, yeah, what's up? Oh, negative 8, not negative infinity. Yeah, might be. Good catch, good catch. That said negative 8, it was just sleeping. That was on its side. You know, it was taking a nap. You see, if one of my new people had volunteered, then I could have patted you on the back when you got that right, instead of saying good catch. Just saying. All right, let's see. Can someone please tell me what the next positive interval is? I mean, okay. I don't remember which name. Trent, please. Next positive interval. Yeah. Good. Okay. What's next? Who's next? Daniel Q. Yeah. Good. That is the last positive one. From 0 to positive infinity. That means the remainder of my domain, negative 2 to 0, must be in the negative zone. There we go. Will they always oscillate back and forth like that? No. I could have just as easily had that graph bounce off the x-axis. And you know, that's a good question. I should have put that in the notes too. What if it had done this? You don't have to draw this, but what if this graph had done one of these numbers right there? So instead of this, it did that and bounced off the x-axis. Then the question I would ask is, can I just say it's positive from negative 4 to infinity? Because it goes to 0, I would argue that no, you can't. You'd have to say negative 4 to 0, and then from 0 to infinity. But of course, that's not what the picture did, so we'll just get rid of that, but it's still a good question. I should have included it in the notes. Alrighty, roller coaster time. We all know we love roller coasters. At the very beginning of my domain, class, increasing or decreasing? Decreasing, 100%. So we decrease from negative 8, not negative infinity, until, well, I'm not going to ask you to estimate as a class because the chances of you all saying exactly the same decimal, not very good. But I'm hoping that everybody in the room could see that right there. That x value is where I'm going to stop decreasing. negative 5.2. Real good. Like that. With a bracket. Because at that point, you used a parenthesis, right? It just feels natural to use a parenthesis right there. I don't know. At that point, we're going to begin increasing. And I would love to hear 29 voices tell me at what x value I stop increasing. Class? -3. All right, that felt pretty good. Here we go. -3. Brackets. Now I'm decreasing again, clearly. At what x value do I stop decreasing, class? Whoa, thank you, 4 or 5 gentlemen. The rest of the class just kind of went to sleep on us. I'm not really sure. Maybe I should record early in the day when people have more pep in their step. What's this kid? After -1, my graph will increase until what x value, class? 29 voices. 2. Moo, he says. Sound like you said moo. 2. -1 to 2. And then after that, we'll decrease. For all, infinity. Now some of you might be saying, but Mr. M, this graph doesn't go down. How could it be decreasing for all, infinity? And I say, remember, what we're doing is we're describing where our graph is doing things. So even though this graph may appear to be flattening out, unless we've been told for sure that it goes flat, which would be constant, we have to assume that it's actually decreasing forever. And even if this is a horizontal asymptote, it'll never reach it, but it will approach it forever. So it would still technically be for all infinity. That's the background information. You don't even need to turn it over. I'm going to talk about what's on the back before we turn it over. What's on the back is information regarding things called extrema. Local and global extrema. What that means is tops of bumps and bottoms of bumps. That's literally what we're talking about here. So we have local maximums and local minimums. Local meaning in the general vicinity. So if you were right here, this is the lowest point in this general vicinity. So we could say that this point is the local minimum. This point is the highest point in this general vicinity. It's the local maximum. Once again, the lowest point in the general vicinity, meaning all the points that are immediately around it are going to be higher than it. Local minimum. All the points immediately around this one are going to be a little bit lower. Local maximum. So local just means in the general vicinity. I would also like to point out that this is the lowest point possible on this graph. So not only is it a local minimum, it's also your global minimum, also known as absolute minimum. All this is on the other side, so don't worry about it. Absolute or global means on the whole graph. Like this is an absolute or global maximum. This is a local maximum. This is also a local maximum. This is a local minimum. And guess what? This endpoint is also a local minimum. But this is not a local maximum because it's not included. So we can't actually talk about that point as being part of the graph if it's not a point. Yes, sir. Ilya, right? Yep. So we, by definition, you couldn't say that this graph has a absolute maximum, because you could get infinitely close to this point, which means there is no highest value there because you could continue to get infinitely closer. So for this one, we just wouldn't say there was a global max, because there isn't always a global extreme value. But if they exist, we say they do. Nobody asked that earlier. It's a good question. So what is really on the other side that's super duper important? other than those vocabulary words, is the sentence that I've typed in bold, there and there. It says when you're going to find a local maximum, when you will find a local minimum. A local maximum will occur every time your graph goes from increasing to decreasing. So when your roller coaster stops going up and starts going down, you found a maximum. And a local minimum will occur every time your graph goes from decreasing to increasing. So the moment your graph stops going down and starts going up, you found a minimum. That's the most important information. I had one more thing to say regarding that. Now I'm struggling to remember what that was. I don't remember. It'll come to me. But you do have to talk about a point that's on the domain. You can't use numbers that aren't on the domain. So it only occurs, like I said, increasing to decreasing, maximum. Oh, I remember what it was I wanted to say. Decreasing to increasing, minimum. What I wanted to say was, when you talk about a maximum value or a minimum value, you're literally saying the y value there. So I could say this graph has an absolute maximum of 5 at x equals 3. So where things occur are x values. What those things are will be your y values. I have a minimum of -1 at x equals -2. You guys see how that's working? That was the last thing I wanted to say about it. Do you have questions for me about domain, range, positive, negative, increasing, decreasing, maximums, or minimums? It's a lot of words. No? Alrighty, nerds. I guess we'll finish it up tomorrow then.